All right, so we're going to look at circuit topology to get a working definition of some of the terms we use. So we have 5 branches, 3 nodes, and 3 loops in this circuit. I'm going to highlight the branches. They are simply the elements in the circuit. Now, if I highlight the nodes, it looks like this. Node V1 is going to be the entire left shoulder of this circuit, all the way up until the beginning of the elements that are attached to node V1. If I highlight node V2, it's the same story, just on the right side. The ground node is larger. It's going to be this entire bottom half of the circuit. The reason that the ground node is larger is because there are no elements in between the ground connection and the beginning of these 4 branches or elements. If there were to be, let's say, a source right here, this node would split into 2 and look something like this. This circuit is relatively straightforward in the sense that we can inspect the circuit and see that we have 1, 2, 3 loops. In the event that you're dealing with a circuit that has a more complex network, you can use the formula to the left over here. Branches minus nodes plus 1 will equal the number of loops. And in our case, 5 minus 3 is equal to 2, plus 1 is equal to 3 loops. When I work through this solution, I'm going to use this convention in the image. This image serves to remind us of a couple different things. Conventional current flows from higher voltage potential to lower voltage potential, and a voltage reading or a voltage calculation is a difference between 2 points. So when you go through your circuit to label the voltage polarities and current directions, don't worry about making a mistake. Just focus on being consistent with what the image shows you. So that means that you should make sure the tip of your arrow is at the negative lead and the tail is at the positive lead. All this is saying is that the current is flowing from higher potential to lower potential, like I said. A good way to think about this is if you were in class using a multimeter. Your black lead would be down here and your red lead would be down here. And when you hold the multimeter this way, it implies that you're expecting the conventional current to flow from the positive side to the negative side. In the event that you receive a negative reading for your current, it's not incorrect. It just indicates that you have flipped your leads. So don't panic if you get a negative current value. It just means that your sign convention is doing what it's supposed to.